Okay, so let's try 2.2 one more time. Okay, welcome everyone. This is Mr. Datwin's math class, and this is going back to 2.2 powers of 10 and 0 exponent. So the first thing we're going to do this time, we're going to actually get you to understand how the zero exponent rule comes about, and then the second will be writing numbers as powers of 10. Okay, so in this chart, I'm going to drop some numbers, and this is the number in words. This is the standard form. And over here, we're going to write it as powers. Okay, let's start with the number 10 million. And what does 10 million look like when you write it as a number? Well, it's 10 and then followed by 6 zeros. And to write this as a power, really, it's just as a power of 10. It's really just counting the number of zeros that you have is the easiest way to do it. So this is 10 to the 7. Okay. Next number we divide this by, if we keep dividing this by 10, the next number will be 1 million. And there we have 1 million in standard form, and that'll be 10 to the 6. So take note of what's happening with the powers over here, okay? Divide this by 10 again, and our next number will be 100,000. 100,000. And that's going to look like this. Okay, and that is 10 to the 5. Divide this by 10 again. This is all we're doing. We're just dividing by 10 every time. Next number will be 10,000. Okay, and then the power for that is 10 to the 4. Divided by 10 again. Okay, that'll be 1,000. So I want you to observe what is going on with the powers here as we're dividing it by 10 every time. Okay, so that's 1,000. And that's 10 to the 3. Okay, I'm going to divide it by 10 again. Oops, not 40. I'm going to divide it by 10. Divide this by 10 again, and our next number will be 100. There we are. 10 to the 2. Divided by 10 again. And this is going to be 10. And divide this by 10 again. And what number do you think we have? 10 divided by 10, I think, is equal to 1, is it not? And what do you think this exponent is going to be? Notice it's subtracting by 1 every time. So here, 1 minus 1 would be equal to 0. So this is what we're trying to highlight for you right here. Okay, the 0 exponent. Okay, and this is going to work for any number or any standard number that we use. Let's try to use it with powers of 5, for instance. Let's start a new chart here. Let's do, let's say 125, let's say. 125. Takes longer to write it as a word than it does to write it as standard form. 125. Okay. Let's say we're going to make another chart here, this time for powers of 5. Watch what happens to the powers of 5 in their exponents. Okay, as we divide this by 5, oh, pardon me, not 10. This time we're using powers of 5. Okay, well, what is 125? If you want to write this as a power of 5, this is actually 5 to the 3. Okay, I'm just trying to prove to you that this is true for any powers that you use. Okay, and eventually we're going to end up with 5 to the 0. And what is 5 to the 0 going to equal to? It should equal to 1. Okay, our next number after dividing this by 5 would be, well, 25. And that looks like this. Okay, and what is 25 as a power of 5? Well, that's just 5 to the power of 2. Divide this by 5 again, and we're going to get 5. Yes? And that is 5 to the 1. Notice I'm just reducing the exponent to 1, okay? Then finally, divide this by 5 again, and what are we going to get? What's 5 divided by 5? Well, that's 1. Okay? 1. And what's the exponent on this 5 now? 5 to the 0. It's reducing by 1 every time. So our final one is 5 to the 0. And here it again. This is an exponent of 0. So guess what? Here's our law or rule for 0 exponent. Any number or any integer base to the exponent of 0 is equal to 1. Okay? So that is the rule that we're going to derive for 0 exponent law on the next page. Okay, so basically, 0 exponent law states that power with an integer base okay, and that means integer as in -1, -2, -3, -4, or 1, 2, 3, 4, positive 1, 2, 3, 4, other than 0. Okay, the base cannot be 0, in other words. And if this integer base has an exponent of 0, and it'll be equal to 1. And we derived that in those two charts that we just did, okay? But in general, if you have a power, let's say a base n to the exponent, sorry, handwriting is a little messy right now, n to the 0, and that's going to be equal to 1, where n, the base, cannot be equal to 0 itself, okay? So let's try out some examples here. What is 4 to the 0? That's very easy. That's just equal to 1. What about -4 to the 0? Notice there's no brackets around this -4, and therefore the base is just 4, and that negative is a hangers on. So this is equal to -1. And finally, -4 in brackets to the power of 0 is equal to 1. And maybe I'll just add another example here, okay? And I've seen this in the assignment, so I might as well give it to you. What if you have a -4 to the power of 0? What is this equal to? Okay, well, you know this -4 in brackets is equal to 1, and that negative on the outside is just a hangers on. Okay, hope that makes sense, and really that's all the examples I can. Hopefully you can work out the assignments after this, but if you have any questions, you know we do have Google Meets. And now we're going into write numbers as powers of 10. Okay. In other words, let's say we want to write, for example, the instruction really is asking you to expand this number. So 3,452. They want you to expand this. Well, they want you to break it up into its digits, actually. Okay. Well, let's look at each of these digits individually. This 3 is actually a 3,000, is it not? Okay. And that 3,000 is being added to this 4, which is actually a 400, which is being added to this 5, which is actually a 50, and finally the 2. Now we have them split up in their, in their values, and now we're going to write these as powers of 10, but first we're going to write it out like this. 3 times, what is 3,000 equal to? Well, you can write that as 3 times 1,000. What is 400 equal to? Well, you can write that as 4 times 100. And 50, you can actually write that as 5 times 10. And finally, the 2 is, well, just 2 times 1. Like so, okay? Now about the powers of 10. Well, we can write this 1,000 as a power of 10 because we did it earlier. As far as powers of 10, this is actually 10 to the 3. So this is 3 times 10 to the 3. This is 4 times 10 to the 2. And this is 5 times 10 to the 1. And finally, what is this as a power of 10? Well, you know that anything that exponent is 0 is 1. So therefore, this is actually 2 times 10 to the 0. And this is the expanded form, okay? So the instructions in the assignment ask you to write it in expanded form. They want you to write in here, okay, as powers of base 10, okay? What if we needed to write it back? If they gave it to you in standard form and they want you to write it in standard form, okay? In standard form, I hope I have enough room here. Standard. Okay. So for example, if they give you a number that is 7 times 10 to the 5 plus 4 times 10 to the 3 plus 9 times 10 to the 2 plus 8 times 10 to the 0. What is this in standard form? Well, let's work it out. 7 times 10 to the 5. Well, if you want to write that as a number, then you can probably just put a, well, you can type it in your calculator if you want, 10 times 10 times 10 times 10 times 10 5 times, but you can also just write a 1 and followed by 5 zeros. 2, 3, 4, 5. Okay, so this is 7 times 100,000. This one is 4 times 10 to the 3 is 1,000. And this is 10 to the 2. 9 times 10 to the 2 is 100. And finally, 8 times 10 to the 0. You know 10 to the 0, exponent of 0 is equal to 1. So this is 8 times 1. Okay, so let's finish this off. 7 times 100,000 is 700,000. 4 times 1,000 is 4,000. And 9 times 100 is 900. And finally, 8 times 1 is just 8. Notice that there's some gaps in here. You don't have a 10 to the 4. You don't have a 10 to the 1 because that doesn't matter, okay? As long as you add these up in the end, this is the number you should get. 704,908. Okay? So good luck on the assignment. I hope this is enough examples for you. Okay? But if not, please bring your questions in our Google Meet. Thank you. Have a good day.